Welcome to mathematics class, direction, cosines and direction ratios, part 2. In the previous class, we have discussed about the direction, cosines and direction ratios. Now let us solve some questions from the exercise 6a. Find the direction cosines of two lines which are connected by the relations L minus 5m plus 3n is equal to 0 and 7L square plus 5m square minus 3n square is equal to 0. Given conditions, L minus 5m 3n is equal to 0. From this, L is equal to 5m minus 3n. Let us call it as equation 1, and second equation 7L square 5m square 3n square. Call it as equation 2. Substituting the value of L from equation 1 in equation 2. L విలువను రెండో సమీకరణంలో ప్రతిక్షేపిస్తే in place of L write 5m minus 3n. Seven L in place of L 5m minus 3n L square m square n square. Expanding (25) a minus b whole square b square minus 2ab 25m square minus 2ab 2 into 5m into 3n 2 into 5 10 10 into 3 30 plus b square 9 n square 7 into 25, 175. 7 into 3, 210. 7 into 9, 175, 5, 180 m square minus 210 mn, 63 minus 3, 60 n square. So 180, 210, 60 can be divided by 30. Dividing by 30, this becomes 6 m square, 7 mn, 2 n square. Factorizing 6 m square, 6 to the 12, 4 3 the 12, minus 7 mn can be split into two terms, minus 4 mn minus 3 mn. Two m taking common, 3m minus 2n. N taking common, 3m minus 2n. 2m minus n, 3m minus 2n. Again, 3m minus taking common, 2m minus n. So this is the factors. Three m minus 2n is equal to 0, or 2m minus n is equal to 0. Two m is equal to 2n, 2m is equal to n. Now, case 1, 3 m1 is equal to 2 n1. This can be written m3 this side, 2 this side, m1 by 2 n1 by 3. Let us call it as 3 equation 3 3m1 is equal to 2n1. Now substituting m 3m is equal to 2n, or m is equal to 2n by 3 in equation 1. So the first equation, L is equal to 5m. In place of m, write 2n by 3 minus 3n. 10n minus 3 3 ja, taking LCM, 10n minus 9n, n by 3. You can take 1. Cosines of first line. So this can be written L1 by 1, L1 can be written by 1 also, dividing by 1, n1 by 3. So this is equation 4. So equating 3 and 4, equating 3 and 4, equating 3 and 4, L1, M1, N1. N1 by 3, L1 by 1, and M1 by 2. M1 by 2 is there, M1 by 2. So 1, 2, 3 are the direction ratios of the first line. The direction ratios of first line are 1, 2, 3. So this is A1, B1, C1. Now case 2, two M2 is equal to N2. This can be written M2 is equal to N2 by 2 or M2 by 1. So let us name it as equation 5. Substituting N2 is equal to 2M2. Substituting N2 is equal to 2M2 in equation 1. That is L2 is equal to 5M minus 3 and 2. In place of N2, write 2M2. L2 is equal to 5M2, 6M2 minus M2, 5 minus 6. L2 is equal to minus M2, or minus can be written as minus 1. So M2 by this minus 1 you can bring this side. L2 by minus 1, M2 by 1, name it as 6 equation. M2 by 1. So equating 5 and 6. Equating 5 and 6. L, M, N. L by minus 1, M by 1, minus 1, 1, and N by 2. Minus 1, 1, 2. The DRs of second line are minus 1, 1, 2. Let us call it as A2, B2, C2. When direction ratios of two lines are known, then we can write the direction cosines. One, two, three. The DRs of first line. 1, 2, 3 R is equal to, if the ABC, R is equal to A square, B square, C square. So R is equal to under root 1 square, 2 square, 3 square, 1 plus 4 plus 9, root 14. So dividing the ratios by root 14 will get direction cosines. Therefore, DC's direction cosines of first line 1 by root 14, 2 by root 14, 3 by root 14. Direction ratios are known. This is how we find direction cosines. Dividing direction ratios by R value under root A square plus B square C square. Similarly, we can write direction cosines of second line. Direction ratios of second line -1, 1, 2. Here R value -1 square, 1 square, 2 square, 1 plus 4, root 6. DC's direction cosines -1 by root 6, 1 by root 6, 2 by root 6. This is how we find direction cosines of two lines when the conditions are given. Now, look at this. Taking the given condition and substituting 1 in second and factorizing, getting the relations between them, we can write the direction ratios. From direction ratios, we can find direction cosines. Now, let us solve one more question. This is from the exercise 6B. Find the angle between the lines whose direction cosines satisfy the equations L plus M plus N is equal to 0, L square plus M square minus n square is equal to 0. Very important. Solution. Given condition, L plus m plus n is equal to 0. So from this, L is equal to minus m minus n. Let us call it 1. And the second one, L square m square n square is equal to 0. Let us call it equation 2. Substituting 1 in 2. Substitute 1 in 2. In place of L, minus m plus n, this can be written as taking minus common. This is L square m square n square. Minus square will become plus. This is only a plus b whole square, expanding this by using a plus b whole square. A square minus plus 2ab plus b square. 2mn m square 2m square plus 2mn plus 2n square. The condition here is minus n square. So this is minus n square. So n square will get cancelled. So dividing with 2, this becomes m square plus mn is equal to 0. Taking m common, m plus n is equal to 0. So from this, m is equal to 0 or m plus n is equal to 0. Case 1, if m is equal to 0, m is equal to 0, substituting in equation 1, that is L is equal to minus m minus n. So this becomes L is equal to minus n This can be written L by 1 n by minus 1. So using m is equal to 0 and L m n, L m n, L by 1 m by 0, m value m is equal to 0, and n the proportionate values 1 0 minus 1. Therefore the drs of first line one zero minus 1 A1 C1. Case 2, m plus n is equal to 0, m is equal to minus n, n becomes minus. So this can be written m by 1 n by minus 1. Let us call it as equation 3. And substituting m is equal to minus n in first equation, that is L is equal to minus m in place of m and minus n. So this is minus into minus plus n minus n, that becomes 0. L value is 0, and writing the proportionate values L m n, n proportionate value minus 1, m1, L value 0. So 0, 1, minus 1 are the DRs, second line. DRs of second line 0, 1, minus, let us name it as A2, B2, C2. Now we have direction ratios of both the lines, two lines. When the direction ratios are known, the angle between the lines, two lines, రెండు రేఖల మధ్య కోణం cos theta A1 A2 B1 B2 C1 C2 mod under root A1 square B1 square C1 square, A2 square, B2 square, C2 square. This is the formula for angle. Then the direction ratios are known. Now substituting the values A1, A2. Now 1, 0 minus 1, 0 minus 1, A1, B1, C1. A2, B2, C2. 0, 1 minus 1. So A1, A2, 1 into 0. B1, B2, 0 into 1. C1, C2, minus 1 into minus 1. 1 square, 0 square, minus 1 square. A2 square, B2 square, C2 square, 0 square, 1 square, minus 1 square. So 0 into 1, 0 into 1, minus 1 into 1 is 2, minus 1 into minus 1 is 1, 1 square 1, minus 1 square 1, 1 plus 1, 2, so 1 by 2 cos theta is equal to 1 by 2, that is theta is equal to pi by 3 or 60 degrees. Since cos 60 degrees is equal to 1 by 2. So the angle is 60 degrees or pi by 3. So this is the angle 60 or pi by 3. Now let us solve one more problem. This is also very important. Find the angle between the diagonals of a cube. Find the angle between diagonals of a cube. So now let us solve this one. Let O be the origin be the origin. So this point is O, and this is x-axis. Let us take it. This is y-axis. Let's take this as z-axis. X, Y, Z axis. So name the points as, this point is A, this point is B, and C, D, E, F, G. It is a cube. Let the sides OA, OB, OC, all the sides equal to small a. Now, the point origin taken as 0, 0, 0, and A on x-axis, A comma 0 comma 0, any point on the x-axis, and B on y-axis, y coordinate A and x z 0, C on z-axis, ABC, D xy plane, A 0, E yz plane, y z, and A B C D F, xz plane, y is 0, x z values, and G is on both the axis x y z, G point A comma A comma A. Now the diagonals for diagonals are OG, AE, FB, CD. Four diagonals. Direction ratios of the diagonal OG x2 minus x1, y2 minus y1. So OG, a minus 0, a minus 0, a minus 0. Direction ratios are x2 minus x1, a minus 0, y2 minus y1, and z2 minus z1. That is a, a are the direction ratios of the first diagonal OG. And take any other diagonal AE, A and E, A 0 0, E 0 A. Same x2 minus x1, 0 minus A minus 0, A minus 0, minus A. Angle between these two lines now angle between the two diagonals OG and AE cos theta A1 A2 B1 B2 C1 C2 by A1 square B1 square C1 square A2 square B2 square C2 square. Substituting the values. So first diagonal ratios A1 B1 C1. Second diagonal A2 B2 C2. A1 A2 A into minus A A into minus A B1 B2 A into A C1 C2 A into A1 square B1 square C1 square. This also minus A square becomes plus A square. A into minus A square plus A square plus A square. This is A square, 3A square. This is also 3A square. This 2 will get cancelled. A square by 3 root 3A square becomes root will get cancelled. 3A square. A square also get cancelled. This becomes 1 by 3 cos theta is equal to 1 by 3, or angle between any two diagonals is cos inverse 1 by 3. Similarly, the angle between any pair of diagonals can be shown similarly. We can show the angle between any two diagonals, any two diagonals can be shown as cos inverse 1 by 3. 4 diagonals are there. You can take any two diagonals. We have taken OG AE, or you can take OG FB, OG CD, or AE FB, or FB CD. You will get the same angle. So we have taken two diagonals OG AE. So angle between any two diagonals, any pair of diagonals of the cube is cos inverse 1 by 3. So taking the cube side equal to A, so the origin as one of the edge vertex, and taking A on x-axis, B on y, C on z. So any point on x-axis is x coordinate A and yz coordinates become 0. Similarly, on y-axis, only y coordinate is A and xy will be 0. Similarly, on z coordinate is A and xy coordinates are 0. D on xy plane, xy coordinates AA and z coordinate is 0. E on yz plane, so yz coordinates are A and x coordinate is 0. And F on xz coordinates AA and y coordinate is 0. And G lies on both the planes, on all the planes. So coordinates of G, A. So taking the points, all the points, 8 points, and the 4 diagonals, OG, AE, FB, CD, OG 1 diagonal, FB, AE, CD. We know if 2 points are given, then the direction ratios x2 minus x1, y2 minus y1, z2 minus z1. O is 0, 0, 0, G is A, A. So using that formula x2 minus x1, y2 minus y1, z2 minus z1, subtracting, these are the direction ratios of OG and direction ratios of AE. A first point, E second point, subtracting x2 minus x1, y2 minus y1, z2 minus z1. Here you can see the points. A is A00, E0, AA. So x2 minus x1, 0 minus A minus 0, A minus 0. So I am taking only two diagonals, OG, OE. You can take any pair of the diagonals and write the direction ratios, and by using the cos theta angle formula, you will get the angle as 1/3 only. So the angle between any two diagonals in the cube is cos inverse 1/3. Practice all the questions. They are very important, long answer type questions. Practice them. Thank you for watching.